Okay, so let's suppose that you have got data and you don't have any other means to generate or to extract rules other than to use the data itself. So in that case, you can apply methods which are called uh, auto rule generation methods. And we'll start with a very basic method, and then we'll go to the advanced methods which are used in say the present scenario. That means is the state of the art methods. So we'll discuss those methods also. So there are various things where soft computing can be used. That means a combination of neural networks, genetic algorithms, and fuzzy logic can be used. We'll discuss these, the other two, that is neural networks and genetic algorithms, the basic approach there when we'll come to those methods later. But the functionality where soft computing approaches can be used includes feature selection. So if you have got multiple features and you want to select the most appropriate features that would represent your problem space, you can use soft computing approaches. Then you can use soft computing approaches for auto rule generation. And one of the methods that is used uh, in this regards is the input space partitioning approach. Okay, and this is the approach that we'll be discussing today. Then you can use fuzzy as say soft computing approaches to to generate a complete fuzzy inference system, or you can have methods, hybrid methods that could be used for parameter optimization of fuzzy rule based systems. So we'll see some of these methods, that how they are actually designed and how do they actually work. So फीचर एक्सट्रैक्शन जो है वो एक स्टैंडर्ड अप्रोच है. आप पहले भी कुछ और कोर्सेज में भी स्टडी की होगी. Some of the standard methods that are used in in feature extractions include principal component analysis, that is also dimensional reduction approach, SVD, which is singular value decomposition approach, and then there are other approaches that are also used in feature extraction. So feature extraction is not something that we'll be discussing in detail today. Our focus would be on the input partitioning, the input output partitioning approach, space partitioning approach. So you have an input space, you have an output space, and you partition your input output space, and then relate the partitions that are present in your input space with the partitions that are present in your output space, and that would represent what a rule is. Okay, so the idea here is that let's suppose that you have got this is your input space and you have got some data here. Okay, and they could be like different clusters of the data that are present here. Okay, and then you have your output space. Okay, and you have got some data set present in your output space. So a rule would be that you take a cluster in your input space and map that cluster to some cluster in your output. And if you can find out a relation between these two, you can call this as a rule. So you can say that, okay, if this is cluster A, so cluster A in my input, if cluster A is present in my input space, then in my output space, you'll always end up having a value in your output that belongs to cluster B. So I can write down a rule saying that if my input belongs to cluster A, so if my input belongs to cluster A, then my output would always belong to cluster B. Okay, so this is a form of a rule that one is used to in any rule-based systems. The important thing here is that you identify a few clusters present in your inputs, okay, and then you relate those clusters with some of the clusters that are present in your output. And from there, you can actually have some relations. Okay, so I can say that cluster 1 here corresponds to cluster X here. Cluster 2 in my input space would always result in a cluster Y in my output space. And I can also say that, okay, let's say cluster 3 would relate to cluster Z in my output space. So I have one-to-one correspondence, right? And this one-to-one correspondence would basically be represented in the form of a rule. So I have actually identified in this particular screenshot, I have actually identified 3 different rules. So I hope this is clear. जी, इसमें कोई confusion तो नहीं है? If there is any confusion, just let me know before we proceed. Okay. So if you are partitioning your input and you are partitioning your output, and then you are actually relating different partitions with each other, then this is the basic approach that is used in the input partitioning, input output partitioning, or input output space partitioning. अच्छा, वह इसका question है कि can two input refer to one output? Yes, that's possible. So let's say कि यहाँ पे आपके पास ये input 1 है, and then you can have another input which is input 2 and here is your output space, और इसके ऊपर मैं let's say कि grid एक mesh दोनों के ऊपर generate कर देता हूँ, right? And this could be, let's say, a different sort of mesh. So I can always say that, okay, input 1 में this partition, input 2 में this partition together maps to this partition in my output space. So that's perfectly possible. Even if you have more than 2 inputs, even then it's possible. तो उस सूरत में वो and connective या or connective आप use करेंगे. So you will say that, okay, partition 1 in my input 1 and partition 6 in my input 2 maps to partition 2 in my output, right? So that's actually possible. Okay. So now, what are the input partitions? So now we'll actually look into this input partitioning methods further into these input partitioning methods. Okay, so what you can have here is that you can have your input space partitioning. So first of all, let's suppose you have got some data, and using that data, you are trying to establish some rules using some data that you have got. So how many different ways can be there to partition your input space? Primarily, there are 3 different ways in which your input space can be partitioned, and there could be like other ways also, but the most common methods are, the first one is the grid partitioning approach, then you have the tree partitioning approach, and then you have the scatter partitioning approach. Grid partitioning approach, the example I've just given you earlier, that is the example of the grid partitioning approach, and we'll go over this in a very quickly. So what happens here is that you have got an input partition. So let's say you have got this is your input space, and here you have imposed on this input space a grid. Okay, and this grid could be of uniform cells, or this grid could be of non-uniform cells that are imposed here, right? So this would be what you call as the grid partitioning. Then you have the tree partitioning and the scattered partitioning. So here is an example that gives you the difference between grid partitioning and tree partitioning. So you can see that in case of grid partitioning, the cells that you have generated over your input space, they are almost uniform. Whereas in case of tree partitioning, it is very similar to a decision tree partition, right? So a decision tree partition is present here. And in case of, but in the first two approaches, that is the grid partitioning approach and the tree partitioning approach, there isn't any overlap between different partitions. One, you have non-uniform grid, and the other one, you have got a uniform, almost a uniform grid. The third one is the scattered approach, and the scattered partitioning approach is the one where you can have overlaps between different partitions, right? So partitioning, scattered partitioning is more closer to the fuzzy partitioning approach. Okay, so let's just see कि कैसे ये partitioning approach use करती है. तो we'll primarily be using the grid partitioning approach here, and towards the end we'll see that how the result changes if scattered partitioning is used. ठीक है. So let's suppose that you want to develop a fuzzy rule-based system using the simple grid partitioning approach. What is known to you? You have got the input-output data with you. The rules are not known to you. And the aim is to extract some rules from the given data. Okay, so how do you actually do it? I'll just give you one example that how this can be done. There are, and this example would be of zero order Sugano model, that how you actually generate rules for zero order Sugano model, right? So if you have got the data present and you don't have actually any rule set, then obviously you can use some approach to actually generate some rule base. Okay, so for that you will have to, because we are talking about fuzzy rule base here, so therefore every so you also have to basically find out the membership functions also associated with your inputs and with your outputs, right? So the first assumption to start with would be that your membership functions could be of Gaussian shape. Okay, so we assume that if you have got some data with you, okay, and let's suppose you have got some data set here, and this data that you have got, this, let's say this cluster has a membership function of Gaussian shape. Okay, so you can always have this assumption. Achha. So a Gaussian membership function is represented by this relation here, okay, where you have C, which is primarily the center of the Gaussian, okay. So this is the center of the Gaussian, which is represented by C here. And then you have the standard deviation of the Gaussian, which is represented by sigma. So this X is your input data points. Okay. So if I assume that my membership function is of the shape Gaussian, then how can I determine the shape of this Gaussian? Gee, anyone? G. So how can you determine the shape of this Gaussian? Yes, shape of the Gaussian. So is the Gaussian of this shape, or it is of this shape? Okay. Or is it of this shape? Okay. Obviously, this would depend upon the data which you have got, right? So let's assume कि आपके पास कोई data set है, तो कौन से parameters ऐसे हैं जिनको आप ट्यून करेंगे in order to find out the best shape that fits your data. So let's say कि इस data set के ऊपर कौन सी Gaussian fit होगी, the data which you have got here. वो कैसे determine होगा? By changing which parameters? जी, और so just have a look at this formula. Okay. So if you look at this formula, okay, there are two parameters which you can change here. And you can't change x. Okay, x is given to you because that's your data set. Okay, you can only play with the center, okay, and the standard deviation. So you can only change these two parameters in order to fit a Gaussian to your data. Right? So ये दो पैरामीटर्स है जिनको आप ट्यून कर सकते हैं. So if I've got let's say data points, इस तरह के data points हैं which are very closely packed, ठीक है जी, versus I've got data points which are of this form, ठीक है. तो इस केस के अंदर गॉसियन जो आप फिट करेंगे वो कुछ इस शेप की होगी, और इसमें जो गॉसियन आप फिट कर सकते हैं वो कुछ इस शेप की होगी. सो इनका सेंटर और इनकी स्टैंडर्ड डिविएशन जो है वो डिफरेंट है दोनों केसेस में, राइट. सो दीज आर द टू पैरामीटर्स व्हिच यू कैन ट्यून, ठीक है. एंड द पर्पस ऑफ दिस ऑटो रूल जनरेशन प्रोसेस वुड बी इनपुट स्पेस के ऊपर अगर आपने गॉसियन मेंबरशिप फंक्शंस आपने फिट करने हैं. सो सपोज आपके पास कुछ डेटा पॉइंट्स इधर हैं और शायद कोई डेटा पॉइंट्स लेट से इनपुट स्पेस के अंदर यहाँ पे पड़े हों आपके पास, राइट. सो दोनों तो इनके ऊपर आपने कोई मेंबरशिप फंक्शन फिट करना, एंड दैट कुड बी ऑफ गॉसियन शेप. तो एक मेंबरशिप फंक्शन इधर आएगा, एक मेंबरशिप फंक्शन इधर आएगा. जितने आपके पास डेटा क्लस्टर्स अवेलेबल हैं, हर डेटा क्लस्टर के ऊपर आपने मेंबरशिप फंक्शन को फिट करना है, और हर मेंबरशिप फंक्शन का सेंटर और उसकी स्टैंडर्ड डेविएशन जो है वो डिफरेंट हो सकता है, राइट. एंड दिस इज समथिंग दैट यू विल हैव टू फाइंड आउट योरसेल्फ कि कौन सा क्या वैल्यू ऑफ सी और सिग्मा होगी. Okay, in order to get rid of that. अच्छा, if your data has got some noise in it, जैसे आयशा ने जो अगर क्वेश्चन आप किया, if your data has got some noise in it, then obviously you'll have to process your data, pre-process it in order to get rid of that noise, ठीक है, before you actually do this. और दूसरी बात यह है कि even there is some noise in your data set, even then because this data set that you have got, you are trying to fit a fuzzy rule based system here, which inherently incorporates some vagueness. Therefore, the element of uncertainty or the element of noise will somehow be tackled automatically because of the fuzzy approach. ठीक है, तो इसमें क्रिस्प अप्रोच अगर हो तो वो ज़्यादा डेंजरस आपको रिजल्ट्स दे सकता है. आई मीन ज़्यादा उसके अंदर अनसर्टनिटीज इन्वॉल्व हो सकती हैं. लेकिन क्योंकि the approach itself, which is fuzzy approach, that incorporates uncertainties in it's inherently included in it. Therefore, so even if it is noisy data, even then you'll be able to get some reasonable output. Okay, right? Okay. So let's just assume कि आपके पास जो input membership functions है, so let's just assume कि आप एक scenario लेते हैं कि if you have two inputs, one is the pressure and the other one is the temperature, and based on the pressure and temperature you want to set in any mechanical plant, you want to adjust the valve opening. That means that there is some flow that is coming in to a vessel, ठीक है, or there is some pipeline, let's suppose उस pipeline में कुछ some fluid is actually flowing. So the parameters that you can that you have in control are the pressure. So you look at the pressure of the fluid that is present in the pipe, and you look at the temperature of that fluid that is flowing, and then based on that you adjust or you find out the valve opening कि आपने कितनी flow rate रखना है. So you primarily determine that based upon pressure and temperature. So pressure and temperature becomes your input and valve opening becomes your output. ठीक है. So यहाँ पे आप देख सकते हैं, तो valve opening is let's say 0.7 या something constant. So that actually very clearly indicates that this type of a model is actually a Sugano model that we are talking about. So what would be the first thing? The first thing would be कि आप pressure के लिए membership functions define करेंगे with and temperature के लिए membership functions define कर देंगे. तो the first thing that you'll be actually doing is that would be a random assignment of membership functions to the pressure domain and to the temperature domain. So आपके पास एक pressure variable है और एक temperature variable है, दोनों के लिए आप let's say different numbers of membership functions assign कर सकते हैं. तो let's suppose कि मैं pressure को low, medium, high में divide करता हूँ और temperature को मैं divide करता हूँ into low, medium, medium high and high. तो temperature को मैं 5 पार्टीशंस में डिवाइड कर देता हूँ और जो प्रेशर है उसको मैं 3 पार्टीशंस में लो partition that contains low pressure, then you have medium pressure and then you have got high pressure, और इसी तरह से टेम्परेचर को आपने करना है. So now the idea is you want to relate the partitions of the pressure and the partitions of the temperature together and then map them onto some sort of valve opening. ठीक है. तो आप ये कह सकते हैं कि if the pressure is low, that is something that you want to determine. If the pressure is low and the temperature is let's say high, then what is the valve opening? That is something that you'll have to determine in this particular approach. So these different membership functions can be distinguished from each other based upon the values of their centers and the standard deviations, और उनकी shapes आप जो है वो different कर सकते हैं. ठीक है. So how can you actually combine these inputs together? Let's say कि मेरे पास एक Gaussian membership function है जो कि किसी input को relate करता है, और मेरे पास एक और Gaussian membership function है जो कि मेरी एक input 2 को represent करता है. ठीक है. So if you look at this diagram here, this graph here, this graph is actually telling you कि let's say कि इधर मेरे पास let's say pressure है, ये pressure की कोई एक Gaussian है, और यहाँ पे मेरे पास temperature की Gaussian. ठीक है. And what happens in a fuzzy rule, if you remember, fuzzy rule के अंदर या fuzzy and here the rule type is of conjunctive nature. That means that दोनों rules, दोनों partitions को, जो मेरे पास pressure partition और temperature partition है, I'm using the and operation and operator between the two. ठीक है. तो इस सूरत में I'll have to take what? I'll have to take either the mean of the two, or I can take the product of the two. So let's assume कि मैं pressure. So if I say that if pressure is low and temperature is high, तो इसमें जो connective है वो and है. So therefore, as discussed previously, I can use the product, the max product operation to combine pressure and temperature membership functions together. तो इस केस में भी मैं product ले सकता हूँ. तो अगर मैं इस केस में product लेता हूँ तो I have, let's say, a 2D Gaussian for pressure and a 2D Gaussian for temperature, which is given here, right? So one is given here, which is the pressure one, ठीक है, let's say, और यहाँ पे मेरे पास जो है वो temperature की Gaussian दी हुई, and they could be of different shapes. So what I can do is that I can actually take the product of the two, and if I take the product of the two, this is what I get. I get a 3D representation. तो एक एक्सिस के ऊपर मेरे पास प्रेशर होगा, दूसरे एक्सिस के ऊपर मेरे पास टेम्परेचर होगा, और वर्टिकल एक्सिस के ऊपर मेरे पास मेंबरशिप फंक्शन होगा, मेंबरशिप वैल्यूज होगा, ठीक है. सो two Gaussians, one of pressure and the other one of temperature, if you take the product of the two, you get a 3D. I hope this is clear. Okay, and you can see that this is my input, this is my input space now. So this is my input space, and this input space के अंदर pressure Gaussian or temperature Gaussian is representing this cluster of data, right? This cluster of data is actually being represented. Okay? And remember, this will not be the only cluster that is being represented here, because the data could belong to different Gaussians of pressure and temperature. Therefore, these bulges that you have got here, they could be of, they could be multiple bulges present here, right? So you can have multiple bulges that could be present here, right? So this is just a representation of one bulge that you have got, of that combines your input and that combines your inputs together. Okay, so input combination. So this is what your input combination would look like. So we are combining our inputs together in order to form the antecedent part of our rule. ठीक है, और ये आप कैसे अचीव कर सकते हैं? Any ideas in terms of formulation? इस bulge को कैसे represent किया जा सकता है? So remember, this bulge here is representing one input partition that combines two inputs together, pressure and temperature. So how can you mathematically take the product of these two Gaussians? One Gaussian representing the membership function of some pressure range, and the other one representing the membership function of a temperature range. G. Any ideas? Okay. So you can have the product between these two Gaussians represented by the formulation, which is called the arithmetic product of the two Gaussians together. Okay. So we'll not go into the mathematical details, but arithmetic product of two Gaussians can actually be taken, right? And where C here is representing the covariance matrix, capital C here, and the small c is primarily representing the center of the Gaussians. Okay, so this is primarily the arithmetic product of the two Gaussians, right? So the arithmetic product of the two Gaussians, where C is the covariance matrix, and capital G here is representing the normalized version of the Gaussian, the 3D Gaussian that you have got here, or the bulge that you have got here. So this bulge here is primarily being represented by this arithmetic product of the two Gaussians. Okay. Right. So C is the covariance matrix. This is the normalized version here. Okay, and normalized version हम इसमें क्यों लेना चाह रहे हैं, क्योंकि what we want is the addition of all the Gaussians at a given point in time, they should add up to 1. ठीक है, and that is for our own simplicity. ठीक है, अच्छा, so this is the difference between the normalized version and the non-normalized version. तो यहाँ पे ये जो आपके पास Gaussian आपको मिला है, या bulge आपको मिला है, this is non-normalized and this is normalized. ठीक है, तो आपकी peak जो है वो 1 पे है और उसके बाद it goes. So you can see here कि this is the if part of the rule. तो यहाँ पे आपके पास pressure है और यहाँ पे आपके पास temperature है, and this is the bulge, this is the partition, this is the relationship of my inputs. ठीक है, तो यहाँ पे membership function जो है वो कुछ इस तरह से shape हुआ हुआ, right? Okay, I hope this is clear. So this is primarily the bulge or the arithmetic product of the two Gaussians, one of the pressure and the other one of the temperature. So here you have the pressure, here you have the temperature, and this is primarily the product of the two, and that actually combines your input space. अगर इस तरह से आपके पास लेट से कि मेरे पास 3 पार्टीशंस थे प्रेशर के और 5 पार्टीशंस थे मेरे पास टेम्परेचर के, सो इस तरह के जो आपके पास 2D गॉसियंस जो आपके पास 3D गॉसियंस जो आपके पास आएंगी, वो दे विल बी ऑन अ 3/5 ग्रिड. ठीक है, तो आपके पास एक ग्रिड है, एक तरफ प्रेशर है, सो लेट्स से कि इसकी 3 पार्टीशंस हैं, एक लो प्रेशर है, एक मीडियम प्रेशर और हाई प्रेशर है, और टेम्परेचर दूसरी तरफ है जिसकी आपके पास 5 पार्टीशंस है. ठीक है, लो, मीडियम, लो एंड हाई. तो टोटल आपके पास जो ग्रिड आपने जो इम्पोज की है वो 15 सेल्स की है, और हर सेल के ऊपर जहां जहां डेटा होगा आपको कुछ गॉसियंस, आपको इस तरह की गॉसियंस आपको मिल जाएंगी. ठीक है, और या नॉन नॉर्मलाइज्ड गॉसियंस आपको इस तरह की मिल जाएंगी. सो जहां पे आपके पास गॉसियन अवेलेबल है, दैट मींस इस तरह की गॉसियन अवेलेबल है, दैट मींस कि देयर इज सम रिलेशनशिप प्रेजेंट बिटवीन प्रेशर एंड टेम्परेचर. और जहां पे इस तरह की गॉसियंस आपको नहीं मिलेंगी, दैट वुड मीन कि यहाँ पे आपके पास जो है वो डेटा अवेलेबल नहीं है. ओके, तो आउटपुट, तो अब आपने इनपुट्स को लेट से कंबाइन कर लिया. we'll go through, I'll show an example of that also, किस तरह से प्रैक्टिकली ही होगा. लेकिन नाउ लेट्स से कि आपने इफ पार्ट डिटरमिन कर लिया, और इफ पार्ट आपने कैसे डिटरमिन किया, आपके पास एक इनपुट्स थी प्रेशर एंड टेम्परेचर, उनकी डिफरेंट पार्टीशंस आपने की, लो, मीडियम, हाई, और इसी तरह से टेम्परेचर की. देन you have the data of pressure and temperature with you, and from there you can determine the membership functions, or the membership functions of the combined input, that is pressure, temperature, combined input together, uh, assuming that the rules that you have got are conjunctive in nature. So you can have those bunches. अब ये है कि आपने उसको ट्रांसलेट करना इनटू योर आउटपुट. एंड रिमेंबर, सुगैनो मॉडल के अंदर भी और ममदानी मॉडल के अंदर, दोनों के अंदर जो आप मैपिंग कर रहे होते हैं वो क्या कर रहे होते हैं, यू हैव गॉट द कंबाइंड इनपुट, and that combined input, in case of Sugano, the combined input is mapped onto your output. ठीक है, if you remember from our discussion earlier. और वो आउटपुट के ऊपर मैपिंग उसकी कैसे होती, थ्रू सम वेट. ठीक है, so you can actually determine your output by getting a weighted sum. And remember, Sugano के अंदर भी weighted sum था. ठीक है, so this is the weighted sum where W's are your weights. The W's are your weights. This is your combined antecedents or combined inputs. You actually multiply your combined inputs with some weight, and you take the average of those weights, sum of those weighted inputs, and that is primarily your output. ठीक है, और इस केस में अननोन क्या है? इस केस में अननोन ये वेट्स हैं. आप ये वेट्स डिटरमिन कर लें एंड यू आर डन. तो अगर इस केस में मैंने रूल एक डिटरमिन करना है विच इज लेट्स से O1, सो व्हाट आई विल हैव टू डू इज कि आई विल हैव टू आइडेंटिफाई कि O1 किन प्रेशर और टेम्परेचर पार्टीशंस को कंबाइन करके O1 बन सकता है. दैट could be determined through the arithmetic product of the Gaussians of pressure and temperature, one thing, and then through some means determining the weight कि इस particular input partition की importance कितनी है. That would be determined based upon the weights. अगर वो हाई इंपॉर्टेंट है, हाईली इंपॉर्टेंट है, तो वेट उसका ज्यादा होगा, अदरवाइज उसका वेट बहुत कम होगा या जीरो होगा अगर वो बिल्कुल भी इंपॉर्टेंट नहीं है. दैट मीन्स कि वहां पे अगर डेटा एग्जिस्ट नहीं करता और उस कॉम्बिनेशन ऑफ प्रेशर एंड टेम्परेचर की इतनी इंपॉर्टेंस है ही नहीं, तो W की वैल्यू कम. So this equation, if you can look at this equation is very similar to what you get in neural networks. ठीक है. Okay. So you adjust the weights and find out the in the outputs. Okay. So let's take an example. तो ये मेरे पास डेटा है which I've got, and this is representing my input space. ठीक है, तो इनपुट स्पेस के अंदर मेरे पास दो फर्ज करें, मेरे पास क्लासिफिकेशन प्रॉब्लम है. इट्स एक्चुअली अ बाइनरी क्लासिफिकेशन. एक क्लास जो है दैट इज ऑफ लेट्स से ब्लैक रिप्रेजेंटेड बाय ब्लैक डॉट्स, और दूसरी क्लास जो है दैट इज रिप्रेजेंटेड बाय the white dots that are here. So this is class 1 and this is class 2. ठीक है, अब इसके अंदर मैंने डेटा फिट करना है. तो this is quite symmetrical sort of a data that I've got. Okay, so let's assume कि आपके पास इस तरह की कोई problem है which is relatively easy. So what would be the first thing that you'll actually be doing? आपने the first thing that you'll be doing is that you will be fitting some Gaussians onto this input space. और ये आपने assume कर लिया Gaussians with some these circles are primarily representing those partitions या grid cells जिन्हें हम कह रहे हैं, और हर grid cell would have some Gaussian associated with it. ठीक है, तो इसकी कोई हर grid cell के अंदर जो Gaussian आप फिट करेंगे उसका कोई center value होगी और उसकी कोई standard deviation. ठीक है, and this is what it would look like if you fit certain Gaussians here. हर bulge जो आपको नजर आ रहा है that would depend upon the data intensity that you have got there. कितना compact है वो data, कितना closely packed है या कितना loosely packed है, और कितना spread है उस data का. ठीक है, और average और mean value उसकी क्या है, उसकी base के ऊपर ये जो है एक तरह के आपके पास different bulges आपको नजर आ जाएंगे. ठीक है, so if you can see if you can try to relate the first figure with a figure A with figure C, you can see कि इसमें relationship क्या आ सकती है, black dots किधर है और white dots किधर है. So you can if you can look at this, so this is the region for the black dots, और ये जो दरमियान वाला region है ये वाला, this is of the white dots. ठीक है, तो ये white dots के रीजन को रिप्रेजेंट कर रहा है और ये जो है ये ब्लैक डॉट्स के रीजन को रिप्रेजेंट. ठीक, so this is the type of the shape that you'll actually be determining, and you can very easily see here कि आपके पास white dots के रीजन के अंदर Gaussians की शेप क्या है और black dots के रीजन के अंदर Gaussians की शेप जो है वो क्या आपके पास आ रही है. दिस इज द नॉर्मलाइज्ड वर्जन, ताकि आपने मैक्सिमम वैल्यू जो है वो 1 में आपने लेके जानी है. यू गेट द नॉर्मलाइज्ड वर्जन हियर, एंड this is the version that you got when you have got some rule associated with that. तो weighted average आपने लेके determine किया है कि which regions belong to the black dots and which region belong to the white dots. तो यहाँ पे we have determined those regions. So all those regions which are in the central part, for example, these regions that you have got here, they belong to the white dots. Okay, these regions here, they are the white dots. So इनके लिए rule जो होगा वो ये होगा कि let's say कि if your input 1 belongs to this grid and input 2 belongs to this region, तो फिर आपके पास जो है वो this is a class of white dots, this is also a class of white dots, and this is also a class of white dots. ठीक है. So this is an example of what 3 by 5 3 by 4 ग्रिड. सो यहाँ पे आपके पास एक इनपुट की 3 पार्टीशंस हैं और दूसरी इनपुट की 4 पार्टीशंस. सो यू हैव गॉट दिस पार्टीशन हियर. अच्छा, द नंबर ऑफ पार्टीशंस, अच्छा, once I've got a rule set using 3 by 4 partitions, लेकिन अगर ये properly perform नहीं करता तो I can increase and decrease the number of partitions and find out कि ऐसे कैसे हो सकता है, यानी किस तरीके से मैं इसको जो है वो बेहतर कर सकता हूँ. So this is an example of 8 by 8 partitions. ठीक है. So total number of cells जो आपके पास इस केस में बनेंगे, they will be 64. And this is a different sort of a data set, and you can see कि इस केस के अंदर भी आपके पास जो partitions बन रही हैं वो they are of different shape, right? तो इस तरीके से आप input grid partitioning आप कर सकते हैं, और and then you can relate the input grid partitioning together in order to determine कि किस तरीके से आपके पास जो है वो rule set आपके पास बन सकता है, right? So the simple idea here is that you actually impose a grid on top of your data, and then fit some Gaussians into that data set, and then determine the relationship between those Gaussians with your output, with your class. ठीक है. तो यहाँ पे क्या हो सकता है, because this is a classification problem, you can always write a rule of this form saying कि if your Gaussians have let's say characteristics, sorry, let me just say this, if your Gaussians have some characteristics of this form, then it's always class 1. If your Gaussians have some characteristics of this form, then again it's class 1. And if your Gaussians have some characteristics of this form, which are primarily represented here, primarily Gaussians of this form, then it's class 2. Okay, so this is how the rules are determined. So based on the shapes of the Gaussians, you can try to determine the class of it. So this is a primary example of classification which can be used in case of auto fuzzy rule generation approach. Okay. So this is the same example with 8 by 8 grid for 2 classes, right? Or अगर आप instead of using the grid partitioning, if you use a scattered partitioning, then this is what you get. And you can very clearly see the difference between the two. इस case में, this is again the example which was used for 8 by 8 grid. ठीक है. तो यहाँ पे आप ये देखेंगे scattered partitioning आपने use किया, you are allowing some sort of, यहाँ पे तो खैर overlapping आपने उस तरीके से allow नहीं की हुई. You can see that some of the cells, so this is not uniform grid. ठीक है. Some of the cells are of different shape. So some of them are smaller, some of them are larger. यहाँ पे ये जो है that is a smaller cell, and this is a larger cell. This would depend upon the data intensity. जहाँ पे डेटा ज़्यादा है वहाँ पे सेल जो है वो लार्ज कर सकते हैं, जहाँ पे डेटा कम है वहाँ पे आपका सेल का साइज जो है वो स्मॉल हो सकता है. In this corner you can see that it's say for example uniformly distributed, तो relatively grid का जो shape है या जो cell की shape है that is they are almost same. तो इस तरह से you can have less number of grid cells or cells, and you can primarily determine your rules accordingly, right? So this is primarily the scattered partitioning approach which can be used. और यहाँ पे आप ये देख सकते हैं the shapes that you have got here, these shapes are quite smooth. I mean the transition between one region to the second region is quite smooth. ठीक है. तो scattered partitioning का फायदा ये है कि based upon the shape of the data itself or the intensity of the data, you can determine the number of grid cells, and then you can also look at the transition from one region to the other region. So region for white dots, say यहाँ से region from the white dots से black dots का जो transition है, that is relatively smooth compared to the transition which we have seen earlier. So यहाँ पे जो transition है, obviously you can see that this transition is not as smooth. It is quite a crisp transition between the two regions. So यहाँ पे ये जो boundary है, that is quite crisp. Whereas scattered partitioning के अंदर ये जो partition है और ये जो transition है from one class to the second class, that is more smooth compared to the others. Right, जी. So this ends our initial discussion on auto rule generation. अगर कोई question है इसके ऊपर तो just let me know. जी, is there any question so far? Okay. So I hope this is an indication that probably you have understood to some extent that what we are discussing. Okay, so that's great. Ujala, thank you very much. Aisha, thanks. So that's a good sign. So the next thing that we'll be doing is that what I'll do is that I'll basically start with the soft computing approach. ठीक है. और सॉफ्ट कंप्यूटिंग अप्रोच के अंदर हम न्यूरल नेटवर्क्स और जेनेटिक एल्गोरिथम्स को यूज करेंगे इन ऑर्डर टू जनरेट रूल्स. दिस वाज प्योरली a mathematical sort of representation. Our next discussion point would be the use of soft computing approaches. So neurofuzzy systems, genetic fuzzy systems, neurogenetic fuzzy systems, या neurogenetic systems. तो ये different combinations of different जो है techniques that we'll basically be studying, that would be in our next discussion. अच्छा, with this I'll also be giving you a paper to read, and then we'll also discuss that paper. I'll upload the paper on neurofuzzy approaches, neurofuzzy and other approaches. There would be hopefully 2 papers that I'll be uploading. So I'll be uploading that, and you'll have to download it and download the paper, go through the paper, and then we'll have a discussion on that paper. Acha, ji Musab, I've already shared the link to the YouTube channel, or I can share it again. लेकिन अगर आप अपना email bank को दोबारा से देखें तो you will find that link. ठीक है. If you are unable to find it out, just email me and I'll send you the link again. ठीक है जी. Okay. Okay. So The next thing that we'll be discussing is I've also uploaded these slides जो कि मैंने अभी आपको दिखाई हैं. You can go through these slides. The next thing is the neuro fuzzy approach that we'll be discussing in our say future lectures. Neuro fuzzy approach के अंदर neural networks और fuzzy लॉजिक को कंबाइन करके एक सिस्टम डेवलप किया गया है which is what you call as ANFIS. ANFIS is Adaptive Neuro Fuzzy Inference System. Adaptive Neuro Fuzzy Inference System. In short, it is called ANFIS. ANFIS is one of the oldest and one of the probably one of the most robust methods in which neural network structure has been used to incorporate a rule, a fuzzy rule. ठीक है. और इसकी डिटेल्स के ऊपर हम जो है we'll discuss these details of this, and this would require say almost one complete lecture. So I'll not because we are left with only 10-15 minutes, so I'll not go into the details of this today. I'll basically do it in the next session. The way I'll do it is that I'll start with an overview of neural networks, and then we'll see that how a neural structure can be incorporated into a fuzzy rule. So I'll request all of you, those of you in fact who have not studied neural networks earlier, कि आप थोड़ा सा न्यूरल नेटवर्क्स के बारे में पढ़ के आएँ, थोड़ा सा गूगल करके आएँ, देखें कि what are neural networks, and so that we can quickly wrap up our discussion on neural networks and move on. ठीक है, तो थोड़ा सा ये होमवर्क आप करके आइएगा. Once we'll have our discussion on ANFIS, immediately after that, and that would be the next class, inshallah, I'll upload the papers, and you'll actually go through those papers, discuss those papers among yourself, and then we'll have a discussion on those papers in the class. Okay. So from now onwards, we'll have these paper reading thing as part of your assignments also. So this would be considered as an assignment. So I hope this is clear.